In this video, we'll be talking about the fundamentals of Amazon Virtual Private Cloud, or VPC. Amazon VPC enables you to launch AWS resources into a virtual network that you've defined. This virtual network closely resembles a traditional network that you'd operate in your own data center, with the benefits of using the scalable infrastructure of AWS. As you get started with Amazon VPC, you should understand the key concepts of a few different components inside VPC. And the first are subnets. So a virtual private cloud is a virtual network dedicated to your AWS account. It's logically isolated from other virtual networks in the AWS cloud. You can launch your AWS resources, such as EC2 instances, into your VPC. You can also specify an IP address range for the VPC, add subnets, associate security groups, and configure route tables. A subnet is a range of IP addresses inside your VPC. You can launch AWS resources into a specified subnet. Use a public subnet for resources that must be connected to the internet, and a private subnet for resources that won't be connected to the internet. To protect the AWS resources in each subnet, you can use multiple layers of security, including security groups and network access control lists, or ACLs. Every AWS account has a default VPC installed in each region, and every VPC has a default subnet in each availability zone in that region. If you have a default VPC and you don't specify a subnet when you launch an EC2 instance, the instance is launched into your default VPC. You can launch instances into your default VPC without needing to know anything about Amazon VPC. You can also create your own VPCs and configure them as you need. These are known as non-default VPCs. Subnets that you create in non-default VPCs and additional subnets that you create in your default VPCs are called non-default subnets. You also control how the instances that you launch into a VPC access resources outside the VPC. Your default VPC includes an internet gateway, and each default subnet is a public subnet. Each instance that you launch into a default subnet has a private IPv4 address and a public IPv4 address. These instances can communicate with the internet through the internet gateway. An internet gateway enables your instances to connect to the internet through the Amazon EC2 network edge. Let's take a look at the following diagram to get a better idea of how public subnets and internet access works. The first things you'll need to notice are that this is a default VPC, and each of these subnets inside the VPC are default subnets. As we just learned, every subnet in a default VPC is a public subnet, and the reason is it's attached to a route table that has a route for an internet gateway. That means these subnets and every instance in these subnets are internet routable. Another way to tell is if you look at these EC2 instances, you'll notice that they have both a private IPv4 and a public IPv4, another clue that they're hosted inside public subnets. For comparison, let's take a look at a non-default VPC. So you'll notice right off the bat that the main route table is a little bit different. Instead of having two routes, one for local and one for an internet gateway, it only has a local route, meaning these subnets and the instances inside are not public subnets, they're private subnets. You can also tell from the fact that they only have private IPv4s and not public IPv4s. Now let's take a look at a more common scenario. This is another non-default VPC, and it also has two subnets, but these subnets are associated with different route tables. So this one here is associated with a route table that does not have a route for an internet gateway, and its EC2 instances don't have public IPv4 addresses, so this is a private subnet. By contrast, this subnet is associated with a route table that includes a route for an internet gateway, meaning this subnet and these EC2 instances are internet routable. This is a public subnet. Now let's take another moment to go over a few more VPC fundamentals, and the first is route tables. A route table, just like we saw a moment ago, contains a set of rules called routes that are used to determine where network traffic is directed. Each subnet in your VPC must be associated with a route table. The table controls the routing for the subnet. A subnet can only be associated with one route table at a time, but you can associate multiple subnets with the same route table. When you create a VPC, it automatically has a main route table. On the Route Tables page in the Amazon VPC console, you can view the main route table for a VPC by looking for Yes in the main column. The main route table controls the routing for all subnets that are not explicitly associated with any other route table. You can add, remove, and modify routes in the main route table. And when we look at all of this in the AWS dashboard in just a moment, you'll see what I mean. Another quick note is, although we just learned that any subnet that's not explicitly associated with a route table gets implicitly associated with the main route table, you can still associate those subnets with any route table, including the main route table. Next are Internet gateways, and just like we saw a moment ago, Internet gateways are what make it possible for subnets and EC2 instances to be publicly routable. An Internet gateway is a horizontally scaled, redundant, and highly available VPC component that allows communication between instances in your VPC and the Internet. It therefore imposes no availability risks or bandwidth constraints on your network traffic. An Internet gateway serves two purposes: to provide a target in your VPC route table for Internet routable traffic, and to perform network address translation for instances that have been assigned public IPv4 addresses. That being said, an Internet gateway can support both IPv4 and IPv6 traffic. And finally, there are NAT gateways, or Network Address Translation Gateways. These enable instances in a private subnet to connect to the Internet or other AWS services, but prevent the Internet from initiating a connection with those instances. Let's check out the following diagram to get a better idea of how these components work. So, notice first of all that we have another non-default VPC with two non-default subnets. By now, I bet you don't need the private subnet label to know from the main route table that this is a private subnet, and that's because it doesn't have a route for an Internet gateway. By contrast, this subnet does have a route in its route table for an Internet gateway, making this a public subnet, and making these instances publicly routable. That being said, because this private subnet does have a route in its route table for the NAT gateway, these instances can make connections to the Internet if they need to do things like download patches. One more thing to be aware of: although a NAT gateway is there to help instances in private subnets reach the Internet, the NAT gateway itself has to be in a public subnet to work. And that about covers it for the basics of Amazon VPC. So if all of that makes sense, feel free to move on.